So, let us understand one by one these points. In these 4 figures, basically we are going to help us in understanding that how reduction in number of variables helps us in conducting the experiments in a cost effective manner. Like in this figure, these are the figures for situations like we have a spherical ball of diameter d. This is kept in a fluid which is flowing with velocity v. This is the average velocity, right. We can do this kind of experiment, or if we have a pipe, in this pipe we have a fluid flow and average velocity is v bar. The diameter of the pipe is d. We want to know what is the pressure loss between these 2 points. What is the pressure at this point? Let us say P1. What is the pressure at this point? P2, and this P2 is always less than P1 because of some viscous effects plays important role. If we have a real fluid flowing through this pipe, then P2 is less than P1 because of that some of the pressure is lost to overcome the frictional resistance offered by layers and at the solid boundary, right. So, this P2 is less than P1. Now, if we do not have the relationship available with us to find out that what is the pressure loss, P2 minus P1 is del P, or sorry, P1 minus P2 is equal to del P. If we want to know what is del P for a given situation, then either we should have a relationship. With the help of that relationship, we can find out and we can give answer to this question. If you can recall the theory which we have discussed, which is known as Hagen-Poiseuille equation, in which we developed this relationship HF is equal to F L V square divided by 2G D. And if F is a friction factor for laminar flow, then 64 divided by Reynolds number. This F for laminar flow is equal to 64 divided by Reynolds number, and Reynolds number is equal to rho V d divided by mu. So, we can calculate this F for laminar flow and can substitute in this equation for calculating the HF, and once we calculate HF, we can find out delta P basically. HF is head loss. So, this is in terms of head and this is del P in terms of the pressure. Both are same thing basically. We can relate this HF is equal to rho W into H, right. We know this relationship, pressure relationship, that pressure is equal to rho GH or W into H, right. But we know that in engineering application or in nature even, we do not have the laminar flow. Generally we have turbulent flow, and for turbulent flow we do not have the exact analytical relationship for calculating the F, right. So, and let us say suppose we do not have this relationship, then how can we get del P? For that we need to conduct experiment, and with the help of that we can give answer to this question, that what is the del P. So, for that we must know that what are the independent variables involved in this physical phenomena. So, this is written here, del P over del X is equal to function of del P over del X. What is del X? Del X is the distance in axial direction or longitudinal direction. Del P over del X is equal to function of diameter. So, this del P over del X is function of diameter of the pipe, density of the fluid in the pipe, viscosity of the fluid and average velocity, right. So, this physical phenomena is function of these independent variables. So, if we want to know what is del P over del X for given diameter, for given density, for given viscosity and for given velocity, we have to conduct large number of experiment, right. So, suppose we want to know that what is the relationship between del P over del X and velocity. For that, we have to keep diameter, density and viscosity as constant, and we have to conduct experiment on del P over del X at one axis and V as on another axis, and keeping other variables diameter, density and viscosity as constant, we will plot. So, we have a pipe in most of the lab at the UG level, we have this experiment. You might have conducted this experiment for finding out the head loss or friction factor. So, we have a pipe, and in this pipe this fluid is made to move with difference velocity, and that can be changed, velocity can be changed by just changing the flow rate, right. So, you can conduct this experiment, allow the water to flow through this pipe and at different velocity, you conduct this experiment, find out del P over del X, this can be measured, and measure the velocity also. This can be measured with the help of simple relationship that flow rate, if flow rate is measured with the help of some suitable device or by collecting water in a tank for a given time, you can find out Q. So, Q is equal to area into average velocity. If we know the diameter of the pipe, then this A is known to us, we can find out velocity, right. So, we can plot this graph, and with the help of this plot we can say that for different velocity what is del P over del X, we can give answer to this question.